Hello and welcome back to the end of the trilogy, Similar Triangles, SAS Similarity Notes. So SAS stands for side, angle, side. If the length of two sides of one triangle are proportional to the length of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So we're going to set up proportional statements. We're going to see if the angles are equal to each other, and if so, then we have similarity. So let's go ahead and let's take a look at example 1. So we want to determine whether the triangles are similar, and we want to explain our reasoning. So we're going to start off with the sides. So when we look at this, we see that we have side length TW and we have side length WY here. So TW corresponds to WY. So TW, that has a length of 10. WY has a length of 20, and this reduces down to 1/2. The next one we have is WZ. WZ. This corresponds to WX. WX. And that is 11 over 22, or 1/2. So you have this side length works with this one. This side length corresponds to this one. So we want to find this angle in the middle of them. This angle in the middle of them. And when we look, is angle W congruent to angle W? And as a matter of fact, it is. So by side angle side, similarity theorem, triangle TWZ is similar to triangle YWZ. So that is our reasoning. By the theorem, they are similar, and we're showing it with this work right here. Let's take a look at example 2. So we want to find QN and we want to find PO, and we want to justify our answer. So first off, we have to show that these two triangles, and that's this small triangle right here, and this larger triangle that's basically behind it or on top of it, however you want to view it, are similar. So I'm going to start off with my side length. So I want to look at MP, and I'm going to look at MQ. So MP corresponds to MQ. MP has a length of 8. MQ has a length of 5. The next one we're going to look at is MN and MO. Well, MO is the long one. MN is the short one. MO is 6 plus 3 3/5. That gives you 9 3/5. MN is 6. If we divide this out, we end up getting 8 over 5. So we got these two. Now we want to see the angle that's between the two of them. The angle is M. So angle M, well, you better believe that that is congruent to angle M because it's the same angle exactly. So because of that, so by side angle side theorem, triangle NQM is similar to triangle OPM. Now we can find the sides. So find QN and PO. So we have that MP is corresponding to MQ, and then we have that PO is corresponding to QN. So one of our sides, MP, corresponds to the smaller one, MQ. And then our other side of our triangle, PO, corresponds to the smaller side of the other triangle, QN. Fill in what we know. MP, that's 8. MQ, that's 5. If you wanted to, you could use the other side, but it's already got fractions, and this already has fractions. I don't want to put too many fractions in there. So this is going to give me x plus 2.25, because a quarter is the same as 2.25. And this is going to give me over x. Cross multiply. 8 times x equals 5 times x plus 2.25. Distribute, distribute. Again, cross multiplication gets rid of the fractions. It eliminates whatever denominators we had. So that's why we just have it on the one line. We don't have anything in the denominators. This gives me 8x equals 5x plus 11.25. Get rid of the smaller x because I only want x on one side. So minus 5x minus 5x. That gives me 3x equals 11.25. Divide by 3. X equals 3.75. So QN, well, that was x. So that's going to be 3.75. PO, that's x plus 2.25. So it's going to be 3.75 plus 2.25, which is 6. So PO equals 6. QN equals 3.75. All right, let's take a look at our next example, example 3. So we're designing an A-frame house. The entire house will be 40 feet tall, and the base of the house will be 60 feet long. So we're going to build a second floor balcony around the outside of the house that's 15 feet above the ground. The left side of the house will be 50 feet long, and the balcony will intersect the side 18.75 feet from the bottom. The height of the house bisects the base of the house and the balcony, so calculate the total area. So if we look at the whole thing, this would be like our A, this would be like our B, this would be like our C. Then right here, we can do E and D. So if we look at this, sorry, D and B. This is going to be ACB. And then this is going to be the top part. Our top part is AED. So this right here, AC, as it says, has a length of 50. This is 30 because it is 60, but it's bisecting, so that means it cuts it in half. That's where it's 30. And then this is 40. This is 31.25. This is 25. And we don't know what this is yet. So now we're going to figure out, are these two triangles similar? So we'll start off. AC is corresponding with AE. Well, that's going to be 50 over 31.25, which when you divide it gives you 1.6. Then our next one we want to check is AB with AD. This is going to be 40 over 25. And when you divide that, that gives you 1.6. And like we had before, you better believe that angle A, I don't want it right there. Let's put it down here. Angle A is congruent to angle A. So by side angle side theorem, triangle ABC is similar to triangle AED. D. Again, this is a D. Now we can solve for our last one, this one right here. So we're going to set this up. So we're going to have AC over AE, and this is going to be CB over ED. So that gives you 50 over 31.25 equals 30 over ED. Cross multiply, that gives you 50 ED equals 30 times 31.25. So that gives you 50 ED equals, multiply that out, gives you 937.5. Divide by 50 gives you ED has a length of 18.75. So first we find if the two triangles are similar, and if they are, then we can work out the rest.